Hello class, in this lesson we're going to learn how to prove various properties on the coordinate plane. So to start off, we have this triangle, we know its vertices, and we want to figure out the location of point G1. And to find G1, we want to find the midpoint of side AB, and then go 1/3 of the distance from M to C. So why don't you try to locate M first on your own, then I'll show you my solution for finding M. So to find M, use the midpoint formula. Or we can use that method we use that works in general for when we're looking for points that aren't necessarily the midpoint. Either way, we end up with the point 45, 45. And now we want to go 1/3 distance from M to C. So to do that, we're going to start at M. We're going to the right, so we can add in our formula. So we start at 45 on X. We're going to add 1/3 of the difference of the X coordinate of C and M. So remember, C is to the right, so we got to put that one first. So 75 minus 45. Now I want to do something similar for the Y coordinates. We start at 45. And we're going to want to add 1/3 of the difference of 120 and 45. And if we crunch the numbers, we end up with the point 5570. So now we want to do the same process, but this time we're going to figure out what the midpoint is of side BC. We're going to call that N. So try this on your own, figure out where N is and figure out where G2 is, and I'll show you my solution. So the coordinates of N are 67.5, 85. And we want to go 1/3 of the way from N to A this time. Well, we're going to the left, so make sure that we subtract. We got to make sure we're subtracting our formula. So we're starting at 67.5 and subtracting 1/3 of the difference. Now, N's to the right, so we start with 67.5 and subtract 30. And the same thing for the Y coordinates. We start at 85, subtracting 1/3 of the difference of 85 and 40. We crunch the numbers and we get 5570. Another way you could have found G2 is by going 2/3 of the distance from A to N. Your formula will be slightly different, but you'll still get the same answer. And finally, try the same process using side AC. So the coordinates of the midpoint are 52.5, 80. And the location of G3 is 5570. So what you notice about G1, G2, and G3? They're all the exact same points. They're all the point 5570. And what's true about this point of concurrency? Well, by what we showed in the previous problem, they intersect at a point that's 1/3 of the distance from the midpoint of one of the sides to the opposite vertex. And that length is the length of the median. And we know previously this is called the centroid, that special point of concurrency. And will that be true for all triangles? Yeah, we learned about that property previously, and we could have taken any arbitrarily chosen triangle, followed the same process, and we would get the exact same centroid. So that point's going to be the same for all three of the medians. So we've proven this property using different methods, but now we want to prove that the diagonals of parallelogram bisect each other by using our formulas that we've learned about. So the strategy here to show they bisect each other is to show that the midpoints of the diagonals are the same exact point. Right? If that happens, then you know that they bisect each other. So to do that, we're going to take any arbitrarily chosen parallelogram, and we're going to move one of the vertices to the origin. Right? We could always do that. We could always rotate it, translate it, so we get a parallelogram of this form. Now, what are the coordinates of the other 3 points? Well, we know that a parallelogram has a base length and a height. So for S, this would be a base. So we're going to call the X coordinate B. And we didn't go up or down, so it's going to be the point B0. Now, what about Q? Well, we went to the right about this far, and that distance doesn't have a special name, so let's just call it A. And how high up is it? What's the Y coordinate going to be? Well, it's going to be the height of the parallelogram, so let's call that H. And so the coordinates of R will be what? Well, remember, in a parallelogram, you could always draw these triangles on the sides. And these 2 triangles are going to be the same. They're congruent because of hypotenuse leg, right? The opposite sides are congruent. We have right angles, and the heights are the same. So that must mean that this distance A here is the same as this distance over here. That's also A. So that must mean we're going B and then A, so the x-coordinate must be A plus B. And the y-coordinate is the same as the y-coordinate for Q. That's going to be H for height. Okay, how does this help us? Well, now we want to figure out what are the midpoints. So what's the midpoint of segment QS? Well, the easiest way to do this is to just find the average of the x-coordinates and the average of the y-coordinates. So for the x-coordinates, that's A plus B over 2. And for the y-coordinates, that's H plus 0, which is just H over 2. So this is our first midpoint. And we want to show that the midpoint of PR is exactly the same. And if we do that, we end up with A plus B plus 0, which is A plus B over 2, and H over 2. So let's just write a little conclusion. So since those midpoints are equal, we know that the diagonals of a parallelogram have to bisect each other. In this lesson, we learned how we can prove various properties on the coordinate plane. Thank you for watching this video.